identify the holes, if any, and the asymptotes for each function. First of all, we need to do any necessary factoring, so let's factor this top here. We have f of x equals, and for a review on factoring, see some of our videos on factoring. I'm just going to jump through this step so we can keep moving. This is going to be x minus 5, x plus 2, over x minus 2. Now, nothing cancels out. This is a plus and this is a minus, so we can't reduce that. So there's going to be no hole. Holes only occur in a situation like this. If you look at number 3 here, we had an x plus 1 and an x plus 1. Those reduced. Therefore, there's a hole located at that point. Here, nothing reduced, so there's no hole. Now let's talk about vertical asymptotes. Vertical asymptotes are where the denominator is equal to 0. So we say x minus 2 equals 0. Solve for x. X equals 2. So our vertical asymptote is going to occur at x equals 2. Now a little further down, we've got horizontal asymptotes. So horizontal asymptotes is a quick review. If the power on top is smaller than the power on bottom, the asymptote is at y equals 0. If the two powers are the same, if you have x over x, x squared over x squared, like this, the asymptote will be the coefficients of the leading coefficients here, one over the other. If the powers are in this, like in this case, the power on the top is larger than the power on the bottom, you're going to have no horizontal asymptote. So if the numerator has a larger power than the denominator, there is no horizontal asymptote, none. I should have wrote none here. So in this case, no holes because nothing reduced. Vertical asymptote at x equals 2 because that's where the denominator is equal to 0. And the horizontal asymptote is none because the leading variables, the numerator is higher than the denominator. This is the rule for horizontal asymptotes. Okay, next example, number 8. So first things first, let's factor. So the top we're going to get 4 parentheses x plus 5, and the bottom 2x plus 6. So again, we have nothing that's reducing, nothing that we can cross out. So there's going to be no holes again. Vertical asymptote is where the denominator is equal to 0. We set the denominator equal to 0, which is basically just x plus 6 equals 0. There's no variable here, so you can just take this portion. X equals negative 6. That gives us our vertical asymptote. And then finally, the horizontal asymptote, we look at the powers. So the powers here are the same. So then we look at the leading coefficients, which is going to be 4 over 2. 4 over 2, which reduces to 2. So our horizontal asymptote is at y equals 2. All right, third example, number 9. Factor as usual. So g of x equals x minus 4, x plus 3 over x plus 5, x plus 3. So now we have a new situation here. We can reduce this x plus 3, x plus 3. That tells us there is a hole at this point. What you have to do, when I say at this point, that means you set that equal to 0. So the hole occurs at x equals negative 3. So the x coordinate is negative 3. Now what we have to do to find the y coordinate is plug this value back into the remaining function. So our remaining function is g of x equals x minus 4 over x plus 5. So I'm going to put the 3 in, negative 3, so we'll evaluate this at x equals negative 3. And this will give us negative 7 over positive 2. So the hole is going to be at that point. The x-coordinate is where it's canceled. Plug in the x-coordinate to the remaining function. Evaluate at that point. That gives you the y-coordinate. Okay, now looking at the vertical asymptote, that is where the denominator equals 0. Well, we're looking now at this new function. So x plus 5 is what we're evaluating. So x plus 5 equals 0. subtract 5, x equals negative 5. So our vertical asymptote is going to occur at x equals negative 5. Horizontal asymptote, looking at the powers, so again we have the same power. So we have x squared over x squared, or in this case we're looking at the new function, x over x. Same power, 1 and 1. So we're looking simply at the coefficients. So there's going to be a 1 here and a 1 here. It's unspoken. So our horizontal asymptote is going to occur at 1. 1 over 1 equals 1. Because again, when the powers are the same, you just take the coefficients one over the other and create the asymptote. All right.